So what you got? So what is that?
This aluminum foil, paper, and pencil lead. That's graphite.
Okay, so what we finna do with it?
I'm gonna put it in this flashlight. The aluminum foil.
Let me see the flashlight. Make sure. Show everybody it's empty. It's empty. All right.
Yeah, I'm gonna put in this flashlight I got from Walmart.
Everybody's spaceman. You type him up on Google, he all over the place. Let me see that.
Y'all want to call me spaceman? I'm trying to live up to that name. You know what I'm saying? I wear that name proudly now. I didn't like it at first.
Uh-oh. What's wrong with it? There we go. We got it. Look at that.
It gets brighter and brighter. It ain't like a battery now. A battery, when you turn it on, it gets dim and dim.
See, I just paused and I turned it like, all right, now take it apart and then pull it out and show everybody what you just did. Watch this. We're moving this out the way. This is another one. Putting it out the way.
That's the same thing.
Look at that. That's crazy.
Aluminum foil, paper, and pencil lead. And this is toilet pipe.
That's crazy.
That's
crazy.
Just to make it stay in the middle. You know?
Right.
Mm-hmm. It'll run without that, but if it's lay all around in there, it won't stay in the middle.
That's crazy.
Yeah, I've been there, dude. It's old to me.
It's old.
Yeah, I've been doing this here.
Why did it come on? Watch this. Look at that.
It gets brighter and brighter.
Show it what's on the inside.
What's on the inside of it, though?
Show it what's on the inside. This finna mess up. Watch this.
It just...
Look at that. Look at her face.
Aluminum foil, paper, and pencil lead.
That's crazy.
See, aluminum tracks energy out of there. The paper keeps the aluminum foil from touching the graphite. Graphite push molecules out. So it bring molecules in, that push it out. So then you got negative and positive.
And you got light.
Oh yeah. Well, there's light, there's energy, and I heard that energy could be rearranged, changed form, but never destroyed. So people talk about it's a shortage of energy. No, it's a shortage of know-how.
There you go.
That's crazy.
People come out with the electric car.
I believe Spaceman was onto something with his air battery. What I have here is the same materials he used in the video. A piece of aluminum foil, a dry piece of paper inside that aluminum foil for the piece of graphite to fit, and last but not least, a piece of graphite to go inside the insulated material, like so. Now you guys see how the voltage is still fluctuating? It's only because the insulator has to have proper surface area with the graphite. So when I pressurize my finger onto the aluminum foil and press it onto the insulator, look what we get for voltage. Have you ever seen anything like that before? So I don't believe I can power an LED with this amount of voltage. But with the proper amount of surface area, I think I can increase that voltage output. And the proper amount of pressure, I believe there will be enough current to send electrons into a small LED. But as of right now, I have never built a dry air cell that has been capable of producing up to a half a volt or more. I've actually gotten this thing up to about 0.7 volts if I adjust it properly here. Close. So, let me know what you guys think in the comments below. Today, we are going to be breaking down where the energy source is coming from for Spaceman's air battery. So, what we're going to do is first answer the question, is my body causing the DC voltage in the battery? So what I'm going to do is prove to you guys that my body is not causing this to happen. I have not added any water or any electrolytic source to the cell. It is a dry, insulated cell, a piece of graphite for the anode and a piece of aluminum for the cathode. So when I hook this up to my voltmeter, one thing I did notice after leaving it out overnight, the voltage increased on the cell, which does lead me to one theory on where this energy could be coming from, and that is hydroelectricity. Check this out. Thanks to Spaceman's air battery and Google AI, I have now came up with a design for a battery to run indefinitely on hydroelectricity, with no maintenance required to keep the battery maintained. Thanks to Google AI and its calculations with other scientific studies on hydroelectric cells, it is determining that with 100 hydroelectric cells with dimensions of 3 centimeters in length and 1 centimeter in diameter, I should get a significant current output of 1 to 5 milliamps at 3 to 4 volts. And the cell is only going to be roughly 10 centimeters by 10 centimeters in dimensions and 3 centimeters tall. I'm officially taking renewable energy to a whole new level. Get ready for the upcoming updates because you are not going to want to miss them. Peace. Today we are going to build a battery that can run indefinitely on hydroelectricity. I also have the key information to make these hydroelectric cells over 7 times more efficient just by using cotton alone. And the other materials I am going to be using is this nickel ribbon, this activated carbon for my cathode, and graphite rods for my anodes. First things first, we will break off our piece of graphite and we will wrap that with a piece of cotton, nickel ribbon. I'm also taking some very fine string and I am wrapping it around the cell so the cotton has a firm connection with the graphite. Alright, and there we have it. So it is a bit thicker than the average paper insulator, but it should be more efficient as the result. Now we are going to stick it in the PLA just like that. For the next video, I will have a vented cap that goes over top of my anode, and it will isolate it from the cathode, and my connection points will be coming out of the bottom of the cell like so. We're going to cut a piece of nickel ribbon about 1.5 centimeters long, and we are going to insert that in the bottom of the cell, about that. Now we're going to take this activated carbon, put a little bit in this lid here. Alright, now for the moment of truth. Let's hook up our other terminal and see what we get for voltage. As of right now, it appears that the voltage keeps climbing. And it is. Look at that. We have a growing hydroelectric cell. This is one of the coolest designs I've ever built, knowing that there is no sacrificial cathode for the battery design itself. So it's more than just a battery. It is a atmospheric energy harvester, or an atmospheric energy generator. The more surface area that you have available, the more voltage and current you can extract from the surrounding environment at all times, as long as you have humidity in the atmosphere. But what we have here is a successful growing cell. What are we at right now? 308 millivolts and climbing. So this proves that the cotton works very effectively and it helps grow the circuit much more efficiently. Now we are going to see what happens when we have 100 cells connected in series and parallel, forming a 5-volt output. Stay tuned for the upcoming video. We're also going to do a power performance test on this single cell as well. We're just going to see how many milliwatts this thing is putting out. Stay tuned. Peace. Today we are going to build a battery that can run indefinitely on hydroelectricity. I also have the key information to make these hydroelectric cells over 7 times more efficient just by using cotton alone. And the other materials I am going to be using is this nickel ribbon, this activated carbon for my cathode, and graphite rods for my anodes. First things first, we will break off our piece of graphite and we will wrap that with a piece of cotton, nickel ribbon. I'm also taking some very fine string and I am wrapping it around the cell so the cotton has a firm connection with the graphite. Alright, and there we have it. So it is a bit thicker than the average paper insulator, but it should be more efficient as the result. Now we are going to stick it in the PLA just like that. For the